Hi everyone, in this video I'm going to show you some tips on heating system design, and then I'm going to run through a troubleshooting example where this might be the current state of your heating design and you're looking how to fix it. Okay, so just to explain heating design off to the side here, the principles of the process in H2x is you have a heat source, which could be a heat pump, a gas boiler, it could even be a buffer tank or a domestic hot water cylinder with storage. The common thing between all of these pieces of equipment is if you place them down, you can click onto the outlets tab here, where you can set a flow and return temperature, which will be shown from these outlets here. When you go to use the pipes tools at the top, you can either draw an individual feed pipe, individual return pipe, but I often use this multi-pipe here because that allows you to run flow and return together. So we'll just put an example route that way. You'll notice when we draw those pipes, the flow direction is shown on the flow arrows, but on the return we haven't got a defined direction yet because we haven't got any emitters that dictate that flow. Now, if we use a radiator as an example, we'll go for a generic fixed rating. A left click on the plan will place that, and then a second left click will enable you to connect the tails. If you don't want to connect the tails and you don't have an initial pipe run drawn, you can hit escape and you can zoom into that radiator, hit connect radiator, zoom out, and then drag your tails over to that connection point. You can then do a right click and a drag on your mouse, or you can click on the individual pipes while holding control to delete them both. Note that when you're doing a hydronic heating system, you can't have the flow connecting back into the return. This has to be done via an emitter, otherwise you'll have some errors on the pipework and H2X won't be able to determine which run is the index run for the pressure loss calculations. You'll notice when I've connected that radiator, these two black horseshoe lines indicate that we have changed from a height above floor of minus zero point 0.1, so 100 mil below the floor on the level we're currently working on, up to what would be the outlet height of the heat pump, because I drew straight from the heat pump over to this location, which is 500 mil above the floor. If we wanted to bring those pipe heights up after we've drawn them, you can click onto the pipes holding control and you can change the height there. Say if you wanted them to be at 2.6, and that will bring them up to that higher height. A good way of knowing what height your pipes are currently at is go into the system settings, go into line types, where you can change high level pipes, so anything above say 2.2 meters, and they can show as dashed lines like this. You can also set that for pipes below the floor where we can have dotted lines. And if we go back to the project, you can see that we've got longer dashes for our high pipes and shorter dots for our low pipes. That's the same process for adding things like manifolds. Manifolds will automatically snap to the pipes closest to them if you have a pipe run within that vicinity. But the connection process on a manifold is slightly different. The pipes have to be drawn manually, similar to our older style radiators, and you need to make sure that the flow direction on the manifold matches that on the pipes. So if we draw our pipes from our lock shield valve downstream of the arrow on the manifold, that needs to go to the return, and then we need to draw this one over to the flow. Don't worry about the flow directions when you've only drawn one pipe, just worry about it when you've connected both up like this. That there was just an instance of an unconnected pipe. So I've accidentally drawn that pipe from here to here, and it's not quite connected, and that's indicated by the pipe being slightly transparent. If I do a left click here where we've got the red circle, I can drag that over to our flow pipe and that will connect up. Now, be careful that you don't accidentally connect both pipes into either the flow or into the return, because you'll get a warning like this. You'll also get that warning if you connect it the wrong way around, i.e. the return going into the flow and the vice versa on the other side. You'll get this red dotted line around the manifold. That's the same process for adding FCUs with a heated connection and AHUs with a heated connection as well. Okay, let's apply these principles to our example project over to the left, where we have some connection issues that are causing our manually sized radiators not to give an output. So you can see here that we've got a radiator showing here. This one's currently giving an output, but others aren't due to some issues on those connections. Now, if we take a look at the system design, you can see we've got a heat pump going into the back of a cylinder with storage. The cylinder with storage is going to be where h2x calculates the kilowatt load of everything downstream of this point. If we pull that away from there, you can see that that's connected into that riser and connects and branches off to the side there. The layout of this level from this point is fine, but there are some issues that are causing the design not to calculate. One of them being this radiator isn't connected to the return, and you can see that with this red circle line here. So we can drag that over to there. And if we drag that into the body of the radiator like that, that radiator will now size and calculate an output based on the model chosen. Now, this is another point. If you're choosing radiators from this initial menu here, the radiator sizing isn't based on the two sizes that you put here. You select a manufacturer, a range, and a height or length restraint at this point, and H2X would use this in tandem with a heat loss room to calculate the required length or height and the output. If you're looking to put a manually sized compact radiator in, after you've placed it down like this, you need to do a left click, scroll down, and choose the model from the drop down menu here. If you've done a underlying heat loss design with a requirement for this living room, that radiator would automatically be sized. But if you aren't doing a heat loss, you need to select from this drop down menu here after you've placed it. Okay, if we go over to the left here, you can see we've got one radiator with the transparent pipes, which means that we just need to connect that to our flow and return pipes here. Because this is one of our newer generation radiators, it doesn't matter which way we connect our flow and returns around, but they do need to be connected to the separate flow or return pipe works. So if we drag that over to there and that one over to there, you can see that that radiator lights up and we're now connected because we have a flow direction. If we go up to level 1, you can see here that we've also got our return that isn't lit up because we haven't quite connected it up to the return riser there. So if we do a left click on that pipe there, drag it over to here, that will connect up like so. And we've got our flow and return directions on the route there. And if we go down to the ground, you can see that this manifold just needs flipping round. So if we delete this pipe and delete this pipe, accidentally deleted the manifold there, click on that pipe and delete it, we can click onto the manifold, change it from like right to left question mark, change that to yes. That flips the flow direction on those arrows there. And we just need to move our lock shield valve because that needs to go on the return pipe work. Connect this into here. Sometimes if you get the arrow flying off the screen, it's better to just delete that pipe. And draw it fresh. Like that. Hover over like this to get nice square angles. And if we put our lock shield valve on the return, that should now work and be able to calculate. If you're looking to add a manifold without an underlying heat loss room, the room would be required to do the loops, but you can allocate a kilowatt load onto the manifold here by going to the technical tab and saying that you have, say, 2.5 kilowatts worth of load on there. That will be applied to that pipe and obviously all of the subsequent pipes as you go back to the heat source. Now, if we take a look at some of these connection points, these black lines means that you have overlapping pipes. So what I would do in this situation is drag that back over to there, but take a look how that affects this part here. And maybe just go ahead and delete these connections and neaten it up this way. Left click and drag that over there. Got a kink in our pipe there, so we can drag that straight. Zoom in, click on here when we have the blue cross, and then drag that over to the flow pipe like so. The flow directions will be figured out and the radiators of this type will automatically allocate the lock shield valve and choose which way around that radiator needs to be in terms of the flow direction. If we click on there, you can scroll down on the menu, choose the size and shape of that radiator. So let's say we have a 600 high by 800 wide. H2X will calculate the output based on the flow temperature from the upstream heat source. These blue squiggly lines just means that we have all overlapping pipes, so I'll just redraw these. That. When you're dragging pipes into a radiator, just drag it over the body, and it's more likely to connect that way. And this system should now calculate, assuming that we have all of our radiators sized to what we need. This one here, just want to connect it back up. You may have noticed that I've used the flow and return pipes interchangeably when I've been drawing them out, but they technically are the same pipe type. It's just when you click this one and you draw freehand, that one will appear blue, and when you choose the other one, it will appear red. But when they detect what flow direction they're on, h2x will automatically change them for you. So yeah, don't worry about obviously picking these the right way around when you're choosing them. Model 600 by 900, 450 by 900. The system should now calculate, hit results. Only issue that we're getting is we don't have a lock shield valve on the return marked on one of these pipes, but it could be the way we have them configured. Looking at these risers, it looks like we could common everything through one set of risers. So we go over to 3D, we might be able to get a better perspective on this. So we've got our primaries coming out of our heat pump over to our cylinder with storage. We've then got our pipes coming out of that cylinder. Lock shield valve is coming, the return's coming out lower and the flow's coming out higher, as you can see. If you wanted to alter this at any point, you can click on the pipes in 3D and bring those down to say 0.3 or whatever connection height that lower one is, and it's dropped down that section of pipe that we selected. Now we're looking at these risers. I think they could be tidied up a little bit, so I'm going to go back over to 2D. I'm going to delete a couple of them and keep 2 of them. Maybe take that one and place it on there. Bring this to here. Connect that to there. So we've got one flow, one return. We go upstairs. We can just connect this pipework onto here and onto here. Like that. However, there may well be a reason that there are 2 flow and return risers going through there. So if that is the case, it would be possible to take a feed pipe from here and one from here, connect them up like so. Go up to level 1, trim these, multi-pipe, connect our return, and connect our flow like that. Now, with these pipes being at a lower level and these ones being at a higher level, that should be replicated in 3D. And you can see that those on the first level, so if we turn off the ground floor, those ones are running at a lower height, coming across, going up and then coming back down. So these must be for the underfloor heating. Looks like they drop a little, well, they go a little bit high here. That's maybe due to drawing directly from the risers. If we click onto there, we can match our pipe height adjacent to it, which is minus 100 mil, which is absolutely fine. Minus 0.1. Minus 0.1. Or if you were really bothered about having those connection points showing there, you could delete those pipes. Drag these risers a little bit closer together. This will be reflected on the level below, don't worry. And then drag that into there, drag that into there. And then if we turn on ground floor, that goes and connects up to that manifold. We probably just want to drop this as well to say 100 mil above the floor, and that little section there as well. So I'm clicking on the pipes in 3D, and that's enabling me to drop them. You've got the reference PDF based on the level that you've chosen there as well. So level 1, level 2, and they show relative to where they would be on the plan. Anyway, that is how I would make this design calculate. Let me know if you have any questions, and if you found this content useful, please feel free to leave a like rating or leave a comment if you have any feedback, and if you'd like to see more content like this, you can go ahead and subscribe. Thanks very much, guys.